Okay. Yesterday it was homework for you to write the output Qn and obviously Qn bar for this circuit. Okay. What was the reference? In previous lecture we had considered this circuit made up of NOR gates and we had prepared the truth table. Now we will check. Now someone from you might have prepared a table. For 0 0 you have written Qn to be equal to 1 and Qn bar to be equal to 0. For R to be 0, S to be 1 you have mentioned that it is 0 and this is 1. For R to be 1 and S to be 0 you have written it is 1 and 0, and for 1 1 you have written it is 0 0. Now we will check. We will begin with 0 0. Now suppose both inputs are 0 0, then for NAND gate the output depends on remaining input. If the remaining input is 0, or actually for 0 0, yes, actually for 0 0, irrespective of other input, the output will be 1. What is the reason? Because as it is 0, irrespective of other input, the output of AND gate is 0, and so the output of NAND gate is 1. Here it is 1. Similarly, here it is 1. So here it will be 1 and 1. Check. Okay, you have written it as 1 and 0, but now it is 1 and 1. What happens for 0 1? Suppose R is equal to 0 and S is equal to 1. Now what will happen? As R is 0, Qn is definitely equal to 1. Qn is definitely equal to 1. See, R is 0. So output of this AND gate is 0 and it is not, that is complement, so it is 1. Whereas this one acts as input to the NAND gate, therefore both the inputs of second NAND gate are 1 1, so the output will be 0. So therefore here it is 0, right? Then you can say that if it is 1 0, that means R is equal to 1 and S is equal to 0, then as S is equal to 0, one input to the second NAND gate is 0, so Qn bar is equal to 1. This is equal to 1. Check. It is 0, so output of AND gate will be 0 and it is complemented, so here it is 1. This one acts as input to the first NAND gate, and both the inputs of first NAND gate are 1 1. So the output of AND will be 1 and it is complement, hence Qn is equal to 0. Correct? It is equal to 0. And what happens for R to be equal to 1 and S to be equal to 1? Suppose both are 1 1. Now we will have to take care that as one input is 1, the output of NAND gate will depend on second input. If it is 0, then the output will be 1. And as this input is 1, the output will be 0, that it is maintained. If 0, it remains 0. If Qn bar is equal to 1, then what will happen? This one acts as input. Both are 1 1. So here it is 0. This 0 will maintain this one, and hence here I will have to write the state is maintained. So how I can represent it? I will have to mention it as Qn minus 1. That is previous n minus 1, previous state output. And this is Qn minus 1 bar. It remains as it is. So, in case of the RS flip-flop using NAND gate, 0 state is said to be illegal or invalid. Correct? This is illegal state, invalid state. Why? Because both the outputs are same and it is against the definition of our flip-flop. Output should be complement of each other, but it is not so. If R is 0 and S is 1, then output Qn is a set, it is 1. Obviously, other is the complement. So this state is known as set state. Here it is flip-flop gets set. It becomes, output becomes 1, main output. If R is 1, it resets the flip-flop. Output becomes 0. So I will call this as a reset state of the flip-flop. And when both are 1 1, then the output remains as it is, or there is no change. Right? Now if I compare the truth table with the truth table of flip-flop using NOR gate, in case of NOR gate, R0 S0 is as it is state or no change state, and RS11 is illegal or forbidden state, whereas in case of the RS flip-flop using NAND gate, R0 S0 is forbidden or invalid state, and R1 S1 is no change or as it is state. This is about the flip-flop using NAND gate. Thank you.